Okay, welcome back, mathematicians. I want to talk about one more thing before we talk about the quadratic formula. So hopefully you've seen that before, but if not, um, no problem. So right now, I want to talk about complex numbers, or I. Some people call them imaginary numbers, but I like to stay away from that. Let's use the technical term. In fact, I'm going to go with a different definition that than some people might have seen in their textbooks, right? I'll go with an I squared is equal to -1. Okay, I like this version a little bit better. It's a little less confusing. If I can get an I squared, I know I can replace that with a -1. So that's going to be my goal, right? Another version of it is if I can take the square root of both sides, I is going to be equal to the square root of -1. And that's more typical to what we've seen. But either one of these guys are going to work for us, okay? So next thing I want to do is I'm going to have a couple examples. So let's look at example one here. Example one I've come up with is like something along the lines of -36 square rooted. Okay, so if it was just a 36, I would have no problem, right? I'd break this up into its composites. Um, I'm going to say -1, right? I'm going to separate that out, and I'm going to make this 6 squared, right? Because 6 times 6 is 36, so there you go, 6 squared. Haven't changed anything yet. Just the way things look. Now I could do a couple things, right? So I can separate them out, or if you haven't heard this one before, I've heard of the prison breakout method. If I have two sixes and a -1, these two guys can jump out. So I'm going to have a 6 on the outside and a square root of -1 left over, right? So 6 square root of -1. But hey, look at this. If I have a square root of -1, I can replace that with an I. So let's do that. I'll have a 6i. Okay, so that's going to be one example of a complex number. So square root of -36 is equal to 6i. Another example, I want to do another example where not everything is so neat and pretty. Let's do, how about -20? Okay, so again, I have a lot of things going on in here, not a problem. I'll separate the -1 first. That leaves me with 20. I'll break that up into 4 and 5. And I don't see any squares yet, but that's just because they're hiding. So I'm going to say -1, 2 squared, and 5. Okay, so there's my square right there. 4 is 2 squared, and we should know to recognize these squares. Some of us know them, some of us don't. And then if you're a senior or getting ready to take the PSAT or SAT, we should probably know, I would say up to at least 15, maybe more. Okay, more is better always, but at least 15. Usually don't see more than that on a standardized test, but that's okay. So again, I can pull out a -1. I can pull out a 2 here. So not 2 squared comes out, just the 2 comes out. This guy comes out. And the way I like to look at it is as it's coming out, it has to leave behind the squared, right? Just like this one. As the 6 squared is coming out, the squared gets left behind, okay? And forgotten, I guess. All right, and again, this -1 square rooted can come out. It comes out in the form of I. And what's left over is a square root of 5. Oops, sorry about that. What's left over is a square root of 5. So that's another way we could see these complex numbers. All right, that's a quick short video for you. Thanks for watching. I'll see you next time.